Paramesh, you are preparing for DRDO Scientist B and you have prepared the subject computer networks. So let's
Yes, madam.
start your. So what are the application layer protocols that you have studied?
Ma'am, FTP, HTTP, HTTPS, SMTP, POP, POP3.
Okay. So what is the difference between HTTP and HTTPS?
HTTP is a hypertext transfer protocol, madam, in which we will send the plain text, we can able to access the web servers. Okay, whenever we are searching for something, the plain text will be transferred. So it will be not yet secure. Okay, madam. So that because of this, the hackers may be hack the data of what we are searching in the browser. And HTTPS is secure hypertext transfer protocol, which is the data which we are searching in the browser. It will be secure. It will be initially encrypted by using SSL as well as TLS. Then only it will go to the server side.
Okay. What is hacking according to you?
Madam,
What is hacking?
hacking is nothing but stealing the valuable information to unauthorized person. Like whenever stations, like stations are nothing but no Alice and Bob, when they are communicating to between, if the unknown person, unauthorized person is stealing the information what they are communicating between them.
Okay. You told POP and IMAP. Okay. So what is
Yes,
the
madam.
difference between the two?
The POP is like the POP is nothing but the post office protocol, ma'am. IMAP is the internet message access protocol. The major difference between is the POP is working the port number 110. The IMAP work in the port number 143. Okay, and in case of POP, we can only read the mails only after downloading to our local. Okay, in case of IMAP, we can directly access without downloading, like some partial data of mail we can read without downloading to our local. And in case of POP, we cannot read, modify, delete mails from mail servers. Okay, in case of IMAP, we can able to read, we can able to delete, we can able to modify from through mail servers only. And IMAP is a little securely compared to POP.
Okay. So what is Telnet?
Madam, TELNET is a telecommunication network, madam, like which we will use this protocol for remote access control, madam. Like it will work in the port number 23.
Okay. So what are the other layers that are present in OSI model?
Yeah, physical layer, data link layer, network layer, transportation layer, and section layer, presentation layer, application layer. Should I explain individual layer wise, madam?
No. Can you tell what are the congestion control strategies and on which layer does it works on?
The congestion control, it will be in the transport layer, madam. Okay, the congestion control strategies is the first one, TTL, what to say, exceed. Okay, so whenever TTL nothing but time to leave. Okay, whenever the sender sending a packet, it will some TTL, some some, if we, for example, if the TTL is 5 minutes, whenever the packet is moving from one router to other router, whenever after reaching one other router, the TTL value will be decremented. Okay, 4. And whenever the TTL value becomes 0, then automatically the packet will be discarded there, and it will send the ICMP packet back to sender. Like the TTL is what to say, like TTL value was became 0, like that the packet will be discarded. And the second one is congestion, okay, keep alive timer. Okay, yeah, keep alive timer. Whenever whenever client is requested for a server, if already server is busy with other clients, so it cannot immediately access the client, and it will send a probe message to all the clients. Okay, so after keep alive timer, if the client is not sending reply to the server, then server will disconnect the client connection. It will accept the new connection. Okay, this is the
So
one.
how this keep alive timer is actually controlling the congestion in the network?
This like whenever so many, see, already the server is busy. Whenever so many clients are requesting to the server, okay, it's nothing but it will what to say, it's nothing but the congestion, right? So due to this, it will reduce this, ma'am. Like it will accept the client. Already, see some clients, it will be connected to the server, but no work will be doing. Okay, so it will be connection be established with the client only. So after sending this probe message, if the client is not giving any response to server, then the connection will be disconnected.
Okay. And what if the connection, like congestion, is not disturbing in this? Like
Madam?
connection may be there, but it is not
Okay.
disturbing the network which we are using.
Congestion is there, but it's not disturbing to the network. Now I'm not getting what you are saying.
Okay, let it be. Can you tell what is Nagle's approach?
Madam?
Nagle's, have you heard this term, Nagle?
No, ma'am, I didn't.
Okay.
Can you spell it?
Nagle. It is the name of scientist.
Nagle.
Yeah.
So this is for authentication, right? Like we will use in security, the characters protocol. I think so.
No. We
For
are
authentication.
working.
No. Okay.
Not authentication.
Okay. Okay.
So actually, it waits for some RTT. Silly window syndrome. Have you heard?
Madam?
Silly window syndrome.
Yeah, silly window system. Yes, madam.
Yeah. So there only these type of solutions come. Nagle's approach and Clark's approach. Okay.
Okay.
And there only these timer
Like
management
persistent,
come.
the RTT persistent timer, like whenever the receiver said when the buffer is empty, after some time the sender will send one data packet to the receiver. This is the one.
Yeah.
Nagle approach means. Like silly window protocol is this only, no, ma'am.
What
After
is
some
silly window
persistent
syndrome?
timer, yeah, see, whenever from the sender receiver, the sender will send the data and receiver will consume the data and it will clear the buffer. Okay, whenever the receiver side the buffer is empty, even after the sender is sending the data, means the buffer cannot able to accept the data. Okay, then it will send like advertisement window to sender as a 0. Okay, then after some time, okay, whenever the buffer is full, then the receiver will send a window size 0 to the sender, so that the sender will understood like, so at the receiver side the buffer is full, so can't be able to take more data. Okay, so the sender will take some time, some persistent time, it will wait. After waiting some
Okay,
persistent
Paramesh.
time, it will send one packet. Tell me.
Yeah, Paramesh, what is token bucket algorithm?
Token, like a token ring, right?
Token bucket algorithm.
Yeah, it is a LAN topology. Okay, token ring. So initially the data will be flow from one device to other device as a token passing.
Okay, what I asked is token bucket algorithm, not token ring.
Token bucket algorithm. Okay, token bucket algorithm is nothing but, see, whenever there is a congestion, see, uncontrolled data, sorry. So congestion nothing but the more data. Okay, so the what to say in, like, how to express, whenever there lots of data is there, that we will convert to in a linear manner, or to say like in a flow. Uncontrolled data can be converted to the controlled one.
Okay, few minutes back in congestion when I asked, you told something else. You told the timers. So what kind of congestion this token bucket is controlling?
Token bucket controlling congestion. 1 minute. Keep piling timer. No.
So you can tell what is
Madam.
HDLC?
Madam?
HDLC.
HD, high level data link control, madam.
And where is it used?
It was used in the data link layer, like framing kind of. It will be having SFD and DE. SFD nothing but start frame delimiter, and DE nothing but end delimiter. And inside it will be having some data. It will be keep like in framing we'll use it.
In framing.
Yes, ma'am.
Can you tell some network layer protocols?
The network layer protocols are interior gateway protocol, exterior gateway protocols like routing information protocol, and open shortest path first, link state routing, and distance vector routing protocol, link state routing protocol.
What is the difference between RIP and
OSPF?
Yeah.
Yeah, RIP is a routing information protocol, ma'am, and OSPF is the open shortest path first. This RIP will be used as RIP uses a Wellman-Ford algorithm, and OSPF uses Dijkstra algorithm. In RIP, we will use distance vector routing protocol. Okay, in which the each router will be having sharing the its neighbor distance vector. Okay, and in this case of distance vector routing protocol, in case of OSPF, I mean like a linked state routing protocol, each node will be having the all other nodes linked state. In distance vector, full routing table will be sharing to its neighbors. In case of linked state routing vector, only linked state will be sharing to all the network. In distance vector routing, we'll be having the only local knowledge. Okay. In case of linked state routing, we'll be having the global knowledge. In linked state routing, the traffic, madam.
Yeah, transmission control protocol TCP. Can you tell them
Yeah.
what all does it contains its header information?
In TCP, madam. Yeah, the
TCP.
source port will be there. Source port will be there, which is 16-bit, and distance port will be there. This is the 16 bits, and after that we'll be having the sequence number of 32-bit and acknowledgement of the 32-bit, and also we are having the window size 4 bits, and reserved bits some 6 bits will be allotted. Then after that we'll be having some flags. Okay, urgent flag, push, reset. One minute. Urgent flag, push, reset, synchronization, ACK, some 6 flags will be there. Then after that, the window size will be there, some 16-bit. Then after, we'll be having the checksum and 16-bit, and also urgent pointer will be 16 bits. This is the header format of the TCP IP.
Okay. So you told there are 6 flags. Can you tell which all
Yes,
flags are these?
Yeah, yes, madam. First one is reset, ACK, push, SYN. Fifth one, reset, acknowledgement, push, synchronization, and fin. And sixth one, URG, urgent. That's total 6, madam. Okay, reset, acknowledgement, push, synchronization, fin, and urgent. Reset.
Okay. What is push flag? What is the function of push flag?
Yeah, whenever it is having the push means it will be urgent. Okay, this packet has to reach the destination fastly. So the specific packet will be move fast fast in the network.
Okay. What is piggybacking support?
Yeah, piggybacking nothing but whenever a sender send the data to your receiver has to give acknowledgement to the sender, madam. Okay, but along with the along with the acknowledgement, if the receiver adding a data to the sender, this we call it as a piggybacking, like data along with acknowledgement along with data.
Okay, why is it done so?
To reduce the time, ma'am, like for time consume like separate means it will be time consuming. So within the same packet, we will send data as well as acknowledgement to save the time.
So let's come to the feedback, Paramesh.
Okay,
one thing I want to say that you got confused in congestion control.
Okay.
Because congestion control itself contains that open loop closed loop, and after that it is further classified into token bucket algorithm, leaky bucket algorithm, choke bucket. These things comes in congestion control. What you
Okay,
told
ma'am.
was timers. Okay, you got
Okay.
confused there.
Confused. Yeah. Okay, ma'am.
But at all other places, I felt like it was okay. You answered it correctly, but still,
Okay,
in
ma'am.
a few places, like I want some sharp, direct answers, which I didn't got. Like in push flag, I didn't understood properly. Like what you know was correct, but the way you told it was not self-explanatory. That
Okay,
thing
okay.
was the problem. Okay,
Then what? Like it
and
was like okay. In what way should I express the content, madam, regarding that push?
try to be like use few words and explain the concept. Like it
Okay,
is
okay.
a segment is generally pushed to upper layer with push flag.
Yes, ma'am. Okay.
Okay, so
To the. Hmm.
with this, there will be less overhead.
Okay.
Fine. This
Okay.
piggybacking support is actually used in the lengthy messages for sending the acknowledgement. What you told was that was correct.
That's
So most
okay.
of the
Okay.
answers I think you told were correct. You have read it like conceptually. I think you are very clear.
Okay.
So, but
Madam, this
still like
Nagle,
security part
I
I
did.
haven't touched.
Yeah, this
Uh,
Nagle, I did hate, man. Can you please explain this? What is this Nagle?
yeah, I told you that it is used in the silly window syndrome. Silly window
Okay.
is actually when we have to transmit one byte in an RTT.
Yeah.
Okay.
Yeah.
So in that, it is a solution. So it is wait for one RTT and then collect
Hmm.
data and then fill one MMS and then send it.
This is nothing but silly window. Okay. In that, this okay, this name will
This is a
be
solution for silly window.
solution. Okay. 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 Okay.
Okay.
Okay. Okay.
You can read about it. It's a very simple thing.
I'll no, I didn't heard. I'll go with it. I'll try to read that.
Yeah. And
Okay.
HDLC, you didn't answer it like very properly. It's a two-way handshake protocol and there is no
Okay.
connection
HTLC like high level
termination.
data link control. Yeah. Yeah. Yes, ma'am.
Yeah. Okay.
Okay. Okay.
So you need to revise more. Actually, it's a big subject and I haven't touched the security part in this now. So
Yes, ma'am.
study that part also very, very nicely. Okay.
You can ask me, no
Anything you
issue.
want to ask?
You can ask me the network part also, security part also.
Okay. Security part, I think uh, that Kerberos and those, I think you are already very clear with the algorithms. If I'll ask direct problems, that will be very simple for you.
Okay. Like some logical, some technical doubts will be there now in the
Technical
security
doubts,
also.
this RSA,
RSA algorithm,
BPCL, and I think these all things you
FPM.
might have studied, right? These
Yes, ma'am.
algorithms you
Studied,
might be
studied.
clear with.
Yes, madam.
So these all things are only like most important things. Kerberos
Most
you
important.
should study properly. Where is it used? You should know it.
In authentication,
Digital
we'll use the
signature,
Kerberos, right? Digital
firewall,
signature
yes,
in no, in authentication.
firewall. Yeah.
Hmm. Yes,
What is
madam.
firewall? You should know.
Yeah, firewall nothing but it will it will allow the like, it won't allow the unwanted data, madam. Bad in, bad out will be removed in firewall. Okay.
No, not
So
data, not data. Firewall is not used in data. It can be a machine or
no,
server
pack.
or a router
It
used
can
to
be
control
router.
access network from
Unauthorized
outside
access can
network.
be blocked. Yeah, yes, yes. Like
It
from outside
controls
unauthorized,
access, not
it will control
yeah, it controls
it will
access
control the
network from outside network.
from outside to the private network.
Yeah, just be clear
Yes.
with the terms, okay? Don't tell. And digital
Okay.
signature is used in confidentiality.
Confidentiality. Yes, madam.
Yeah.
And this authentication also, right? Authentication also.
Authentication, yes, authentication is one thing,
Authentication also.
but
Why?
main is
Because
like confidentiality because we are using a
confidentiality
secret
only.
message.
Yeah, yeah.
Huh.
Like this authentication, nothing but like whenever the sender sending, it will encrypt using the sender private key. Then after it will be encrypted again with the receiver, uh, sorry, public key. This is nothing but authentication, like the respect to that I receive the data from the A only, like from Alice only, I receive the data. Nothing but authentication only, right?
Okay, what is message digestion?
Madam?
Message digestion.
Message digestion, nothing but, see, after the data received to the receiver, and the message can't be modified. Okay. So because of this only, initially, so message digestion, nothing but, see, whenever the sender sending a data to a receiver, and no data should be modified in that. And in future, and the sender should not say that I only sent to, like I didn't send to him.
Okay, where do we use actually this message digestion?
The message digestion, like in communication, like secure communication systems, madam, like in public key cryptography, in bank systems, banks,
Main
like
function.
related to.
Main function of message digestion. It is used in hashing, right?
Okay, okay, okay.
Okay. So
Okay,
be
okay.
clear. That's what I'm saying. Just be clear with the terms. Don't
Sure,
answer
sure,
it.
sure.
If you want time, just think about for 5 seconds, 10 seconds, then only answer.
Sure, sure.
Okay, it's a hashing
Okay.
algorithm. And
Yeah.
once we have hashed the message, so can
Okay.
we, like, from the we have applied some algorithm, hashing algorithm on a message. We got
Okay.
some encrypted message. From that
Okay.
encrypted message, can we apply again that hashing algorithm and can we get the same message?
Yeah, yes, ma'am.
No, this is not correct. This is one way only actually.
Okay, message digestion hash. Okay.
Okay.
Okay, okay.
So just be clear with the network security part. Very clear.
Sure, sure.
Okay.
Okay, okay.
Anything else you want to ask?
Nothing.
Okay, Paramish. So
Thank you, ma'am.